Well, hi, and thanks for joining me in my shop here. It's the second day of June. It's going to be another beautiful day here. It's going to be hot sun all day and cool air. It's not likely to get much above 15 here, which means for a beautiful day and more yard work. Yeah, planting flowers and all that kind of stuff. But I have a chance to be in here for a little bit, and I'm going to do a quick recap on where I think I am with this radio. And then look, I have another 227 to give a tryout on. So where am I at with this radio? Well, I think there's basically two primary problems here right in front of my face. One of them is that crackling and popping sound that seems to persist right until I start getting really close to the source, and then it goes away. So I haven't been able to track that down. We're going to take a look at the schematic in a minute and just get in my head all the parts that might be involved in the crackling, because I clearly I'm not thinking about everything that's in here. And number two, the radio signal, after changing tubes and getting things in a better order here for tube strength, excuse me, the antenna signal make it all the way through right to the grid of this tube, the detector tube, and then nothing more after that, which really totally stuck on why that would be. Yeah, bad tube. So I tested this tube in my tube tester. Offhand, I can't remember now. I am remembering. I think it was supposed to come up to 630 and it read 700, something like that anyway. But those aren't exactly the right number. The point is, this tested just above the reject line. So my alternate tube is testing just below the reject line, for crying out loud. So this is, according to my tube tester, this is less likely to work. But it may help determine if the popping and crackling is coming out of this tube itself. Now, I tried to get the popping and crackling out of this tube in my tube tester. That was unsuccessful, but it doesn't prove anything. I just may not have done it correctly, or the circumstances operating this tube in the tube tester may have been different, and who knows. So from here we're going to jump onto the schematic, kind of review this last stage very thoroughly, and get into my head anyway all the possible parts that could be making this crackling. Just about anything in there. Okay, let's take a look. Okay, let's take a look at the schematic here. Excuse me. The tube of great interest is this one here. Now, in terms of snuffing out the signal and maybe the source of the crackling, either this tube or the componentry around the tube. So let's just look at the different components that could possibly cause the crackle. Excuse me. So, just without too much thought, it could be this guy, could be that guy. It's possible it's these, it's possible it's this. Probably not that. It's not too many parts. So this one worries me. So does this one. This guy is a little coil, and if I remember right, do I remember right? We'll retest the radio in a minute. I'm trying to remember if I could pick up the signal here, but not here. I think if that were the case, I'd know right away. Aha! Open coil here. But of course, if this coil is open, there'd be no B plus here, and there was 40 volts here, so this can't be open. Oh my gosh. Well, yeah, lots of I hope it's this tube. Okay, that's about all I can say about that. Oh, by the way, the big capacitors I put over here, and this other one, which one. I think this one here, C7 here. These are supposed to be 0.25 microfarad. I stuck in 1 microfarad electrolytic, and the radio hasn't worked since. That's kind of a curious thing. Am I wrong? Didn't we hear this radio work right off the bat when I got it in my shop? I'm pretty sure we did. So you got to kind of wonder how it worked at all when I found essentially non-responsive tubes in the tube lineup with very low GMs, way below the reject point on my tube tester. How did it work at all? And I'm guessing, this is my crazy guess without thinking about it, that somehow the radio signal was sneaking from up here all the way back to here, skipping these tubes. That's what I think. I don't know. I don't know how to, or some weird combination of the signal getting in and out of here, bypassing the extremely weak tubes. And then when I come along and fix these capacitors, it basically broke that sneak circuit. So suddenly the only way for a signal to get to the speaker is to travel through these tubes, which then turned out some of them were pretty much dead. So that's my theory. These capacitors quieted things because they stopped a sneaky path, a backdoor path through the radio, bypassing all this. So how could it work bypassing all this? Well, you get a strong enough signal on the antenna, you could stick it right on the detector if you had a strong enough signal. You don't need these. Okay, don't argue with me though. Okay, let's go back to the radio and make something happen here. Exactly what we're going to make happen, I don't know. We're going to start with the original tube. I better mark these. Okay, this one has a tube 1 on it, this one has nothing on it. That's how it's marked. Marked with nothing. Everybody happy? Is everybody ready? Yeah. And with my kind of luck, the radio will work. It's not going to work with the low voltage it's being supplied right now. That's for sure. Hook the, oh, there's the click. Well, that one click, that doesn't count. That could be a warm-up pop of some sort. I noticed in this radio, the heater in this tube is quite bright, but in my tube tester it's not nearly as bright. There we are. We got the crackle. We heard it. Again, is that the real crackle, or is that it sounds like the real McCoy there. And what about hearing a little bit from the radio? Let me get my tracer ready. So if you just heard a hum come in the shop, it's my signal tracer that has a hum in it. It's definitely clicking. Okay, that's enough. That's definitely the crackle we're after. Come out, little tube. It's a fight between Philco and Westinghouse. Who will win the fight? There we go. I'm just trying to punch up a little bit of excitement here. Okay, same dim lights. Those dim lights look a little brighter. Is that possible? Is that possible? It's possible because I'm imagining it. Yeah. Okay. Imagination running wild. Radio on. Oh. Little microphonic. Crackle. Okay, that's enough. That's enough. That's all we need. We know it's not the tube because the same crackle. I'm pretty sure that was the same crackle. Microphonic, eh? At least I had one to do that little test. Okay, back on. Full blast. Let her have it. Let's get ready on the crackle finder. It's on audio. Starting over again on the grid of this tube. No crackle. That's interesting. On the grid, no crackle. On the plate. Crackle. So it's the same spot here. Crackle. And on the output. Crackle. Of course. Well, there's not a lot of parts here on the output. And you know, let me just check this side of the input. We hear some stuff. I mean, this is stereo for me, so it's fairly easy, even though I only have one ear working here. You can certainly tell what's popping out of the speaker here versus what's coming out of my tracer. No popping. No popping on the grid side. It's all after this tube. Say, does the popping continue when if I flip the input switch to phono? Well, that's a simple test. Here we go. Pump. Well, tain't that an interesting thing? What exactly have I done? No more crackle. Wow. How's that all fit together? How does that work? So this switch isn't switching the feed to the tube. It's switching the feed leaving the tube. Wait, that doesn't make sense. It switches. No, I misinterpreted this. There's 1, 2, 3. There's four wires going to this guy. Oh, interesting. Let's take a closer look at this switch here. I'm going to be talking about it for a bit. Yes, kitty. Wow. What do you want? What would you like? You want to go outside? Yes. That's as much of a yes as you get from a cat. She turned towards the door right away. So I'm going to let my cats out, and then we're going to take a run at, what was I going to do? Oh yeah, close-up camera. Come on, Shadow, let's go. Okay, here we go. Let's take a look at the switch here. Now the set is still on, I'm telling myself. So here's the actual switch. So if I just set this right in my radio here. It's amazing these little cameras don't generate huge amounts of distortion. There we are. There's a good look at it. So in the schematic, when you look at the switch, the schematic shows, let me just get a pointer. Some kind of pointer. In the schematic, this is shown as a conductive connection. But of course in these switches normally this is some non-conductive material up here. So what they've got instead is, and you can't see them right now, 4 terminals down below. 1, 2, 3, 4. Each one of these metal pieces is brought out as a terminal down below. That's why there's 4 terminals and not 3. Take a close look. We see this coil, which is coming from the plate of the detector tube. So this should have the audio in this coil. The coil obviously is bucking the RF from continuing past it. Now, that wire looks like it's been resoldered to me. Somebody's been here before. Now that could be a troubleshooting technique where that wire was lifted and then somebody else listened for the pops that I am now chasing. The other wires, they do not look like they've been changed. So another possibility is this is not the original coil. I don't think that's very likely, because when I look down in here, when you follow this wire from the coil, there we are, that black one. See how it's kind of woven in here? That looks like it's been there since day one. Let's see if the other end has been soldered. I wouldn't say so. I mean, I can't be absolutely sure. Well, it's right on the outside there, isn't it? It's just kind of bent around the end, the wire strands. The strands look a little flaky. So perhaps this coil is a replacement. Maybe I'm wrong about how this wire runs. I mean, this could have been done 40 years ago. It's a coil coming right off the plate of a tube that has very little plate voltage or drive, but that blue wire just looks different than all the rest. And that's definitely a new solder job there. And this other one doesn't look so good either. But this one's going, this wire's heading into a big cable, so that's got to be original. It's funny how it's got it done there. And I'm just looking for anything. Actually, I'm looking for a little sign somebody wrote that says, here's the problem. Well, I've had this thing running now for quite a while. I haven't heard any crackling. We're not in any position to go hunting for the crackle. Another possibility for the crackle is the actual tube socket. These tube sockets can become conductive for whatever reason. No crackle. No crackle. Okay, no crackle. Now we'll go on to problem. We'll leave the crackle problem out of it because it appears to be gone again. And let's go on to. Hello. Let's go on to. Well, that's a powerful picture there, isn't it? Let's go on to why there's no radio coming out of this. That's why I have this at the ready. I'm going to flip this to RF. I'm going to run through the tubes again. Starting with the antenna.
Yeah, and look, there's always going to be certain ballparks that are going to be difficult to hit the ball out of, whether...
Oh yeah, this is Canada now. Canada's gone basketball crazy. It's Raptors is the professional basketball team. It's the only team in Canada, and the whole country is going nuts because the Raptors are in the finals. So every time I put on the radio, you're liable to hear something about the Raptors basketball team. So that was the antenna. Okay, so this is output of tube number 1. How about input? Input? It's lower. Output?
They see the ball well from
input? Output?
well, and
Input.
Getting her into the street.
Output.
Sure, streets exist.
Getting louder every time. Input.
Two are still hitting the top.
Output.
Be hitting the lineup.
Went down.
Add skill.
Meow. Input.
Sort of like, okay, you get stats from.
Output. Where's the output? Oh, there's no output. Where's the output? It's right here.
The stats have been put up and there's some stabilization.
So that's what's coming out of all these tubes, is the signal we want to hear. Bingo. Right to here. Now, grid onto the detector tube.
Line shift. It's not a straight type of.
Plate of the detector tube. Total silence. Well, not much use chasing it beyond there. Okay, power off. Take our sort of maybe good tube out. We'll put in the microphonic. Now the microphonic tube, that's interesting. The audio microphonic effect is being launched from this tube forward into the radio. We're hearing it come out of the speaker. So that kind of proves the circuit beyond this tube. Sorta. Now watch the radio start popping. This is exactly what. Oh. Well, that came out of here. So there's insulation on my test probe. I'm not actually, and this is an insulated wire. This is just a wire feeding the light. I've just got a there it is, way up there. Just got a LED light there, and of course it has a little wall wart power supply. And I think what's interesting is the noise, which isn't traveling very far. The noise in this wire changes when I turn the light off. To that. Wow, that's worth looking into. But not right now. Just be aware when you do that kind of thing. Back to what we're doing. Okay. Radio signal. Oh, you know, did I made a mistake. I listened for the radio signal using RF. Dumb. Okay, we'll do it right with this too. Then we'll go back to the other one. So what's coming?
I'm trying to think that
what's coming out? RF, nothing. Audio, this is my mistake. Audio. Nothing. And what does the ground sound like? So I'm touching either side of a capacitor. One side's grounded to the chassis, that's this. Listen. And the other side, doesn't that sound similar? What's that say? Short-circuited capacitor? But we measured 40 volts on this plate. That means it should not be shorted. Let's repeat that. Conflicting measurements. Okay, stay right there. 200 volt scale. So I'm going to read essentially from the cathode, which is the heater. Oh, there is a cathode in here. There is a cathode. Cathode. Okay, I'm going to read. Let's go across the capacitor to start with. Oh my gosh, is that it? Okay, from the plate. I thought I saw 40 volts here. Sure don't now. Something going wrong here with this, how I'm doing this? 200. Let's look for plate voltage on another radio, another tube. Plate here. Oh, what am I doing wrong? What's going wrong here? Am I not making a ground connection? Let me get a really good ground connection. Here's one. Right there. What's going on here? Plate here. Oh, for crying out loud, my... How many of you saw that happen? How did that come out of there? Get in there. Well, that explains that. Okay, back to plate here, 40 volts. Ooh. Hot diggity dog. Minus on the plate. Okay, let's think about this. So let's get over here so you can watch exactly what I'm doing. You can imagine having a tripod in a shop like this means the tripod legs get caught up in all the wires all the time. All the wires all the time. So this is the plate, and I'm reading it to the chassis, which maybe is not the right place to read it to. Cathode would be better. Definitely something going on here. The plate voltage. I'm sure I measured this at 40. Minus. How can you get a plate negative? Because that's not the plate. Because that's the cathode. Wait a minute. If that's the cathode, I gotta figure out what's what here. I gotta figure out what's what. Yeah. Let me sort out. The wires are just a little bundled in there. It's a little hard to figure out. Let me figure out who's who here. Here. Look at the tower of power in the meantime. Okay, so the tube we're working on is this one. This is the only one with 5 pins, by the way. All the other tubes have 4 pins. We see the 2 heaters here with the F for filament, plate, grid, and cathode. I see the cathode is grounded right at this point. Is that really a ground point? Yikes. Yes, this is a major grounding point in the radio right here, just behind this terminal, which I'm using right now as a ground for my meter. You see clearly the wire. So this is a ground point. So this capacitor is grounded at one side, this coil. Wait a minute, what's going on here? This isn't just a coil, is that? This is a transformer, because you see 2 wires here and 2 wires here. Transformer. I'll have to look on the schematic itself. I'll sort out what this transformer actually is. So pretty easy to remember: plate, grid, cathode. I can recognize the plate and the grid, so this last one is the cathode, and it's just tied to ground anyway. So control, right. Detector choke coil, right. What do they call this? Detector input transformer. Yeah, actually when you look at it, you can see that if you assume these 2 wires are the output here, then they're going straight to this combination resistor capacitor. So this is a grid leak technique here. They put a big resistor here, and a negative voltage will build, the grid will build its own negativity with a big resistor here. But the problem with the big resistor is you can't get a signal past it or through it. So you bypass this big resistor with a capacitor and let the signal reach the grid while you're building up. So this is a self-biasing technique, very, very common. Very common. There's nothing jumping out here at me. Okay, well, let's see. We got the signal here. We got nothing here. Nothing here can only be. And what happened to the 40 volts? This guy must be shorted. We should test this directly. Yeah, let's do that. I think it's all about this capacitor now. That's my theory. I'm going with it. Now we'll get some feel powerful looking at those tubes there. Actually, I look pretty skinny, don't I, really? Not so powerful. It didn't make my hair come back either. Okay. Great idea here. The radio's still on. Don't forget. So we want to look at, so I've already looked at the voltage. Radio off. Okay, power off. I'm going to leave the tracer on. This terminal is grounded. This one. So then we want to test across, and it goes only to the plate and to a switch, which currently I think is open. What do we get? Let's check first here. We should see 0. 0. And here we shouldn't see 0. We don't. My theory's going down the drain rapidly here. Theory failing. Frankly, if you have a ground on the plate, well, I don't know what would happen here. Let's get even more direct. Well, that does not seem to be open. The theory has failed. So how do you get the mystery non-existent 40 volts here now? Where did it go? So that's just a ground wire. This is really, there's just not much to this at all. I'm going to end up saying the socket is causing the problems, which aren't there anymore. The crackle problems. What if the tube pin's not making contact? I'm plugging it in, but maybe I'm not. Where's the 40 volts come from anyway? Quick, back to the schematic. Quick recharge, then we'll go to the schematic. Well, what am I trying to prove here now? Let's just go over it again. Radio sound clears a bell on the grid. Nothing showing up at the plate. Cathode, what if the cathode is open? What if this wire is not doing its job? So I should be able to read a solid ground on the cathode. I don't think I've ever tried that. Let's get in there and take a look. Okay. Check to make sure the cathode is grounded. Love that shot through the tubes. Okay, cathode is grounded. Ohmmeter, please. got too much junk on my bench here. Oh, yesterday morning, rather than be in the shop here, I went out yard sailing. I got a couple of interesting yard sale purchases. I'll probably throw a video together later. I'll let you see my yard sale finds. Cathode grounded. Test. Cathode. Yeah, cathode grounded. I can't believe I'm stuck on this. This is so right there. We've got the microphonic tube in there right now. Let's have a listen to that. Now there's coils associated with, well, maybe not with this tube. Associated with 4 of these tubes have coils and tuning. The first one, this one, is called a antenna tube. It has no tuning coils, this one here. Radio's on. Why so silent? Because I threw the switch over here. Throw it back. Switch is back. Okay, volume is almost full. Where's that? Now back to put my signal tracer back on radio here. Antenna.
There's a long term in July or August here as the
signal from the antenna through this gigantic radio all the way to the grid of the detector without adjusting the tracer level.
Away. When we come back, final segment of the program, we'll break down the DFS schedule
it's a
for
beautiful
you today.
signal.
Give us our thoughts on that, and of course, chat a little bit about game number 2 of the NBA final.
On the game number 2 of the NBA final. Hey. Okay, so now we're hearing it with the RF probe. We shouldn't be. So if I go on the other side of the choke coil, they turned up. So it's still a little there, but that's turning my tracer way up. What we should hear is audio. So I'll flip my tracer to the audio. Good thing I bring my fingers with me everywhere I go. Don't leave home without them. Audio on the grid. Audio on the plate. It's a little wee bit there. Audio after the coil. Oh, son of a gun. See, there's a little bit of something there. But what's really wonderful is no audio. No, there's no wonderful. There's no detection going on. It's right there. Where did the microphonic sound go? This thing's getting just weaker and weaker as I go. For sure, that's the microphonic tube. Yeah, because I've got the original one right here. Why nothing? Because I flipped this switch. Flip it back. Somebody, anybody. Oh. There it is. Microphonic. Volume shouldn't affect it. So assumably the microphonic tube has a small variation in the plate current, which is being translated into the sound you hear coming out of the speaker because the elements in the tube are moving a little bit. So in a sense, that's an output from this tube. The output from the tube is showing up in the speaker. The input to the tube is not getting anywhere. How can this be? I might have a tube extender for that socket. I don't think so. Let me check and see. Okay, so simply because I'm running out of things to try here, I'm going to pull the tube out. I'm going to probe down in the socket and see what gives. Does that make sense? I think it's harmless. So I'm going to pull this out. Yeah, I don't think anything bad can happen. Just a big pop. Big pop. Pop, pop, pop. Now, what are we looking for? We're looking for first DC voltages to ground. Okay, so that's on ground. I know that that's cathode, grid, plate. Plate. This has got to be plate. Holy smokes, 62 volts. Can you see that? It says 62 volts on my meter. But I don't see 62 volts here. Oh, I do now. How's that work? Put the tube in, there's no 62 volts. 62 volts coming with no power behind it. 60. How do you get 62 volts there? How do you even do that with the tube out? That's 62 volts on this switch. There's an explanation for the pop. When I turn the switch, 62 volts bopping around there. That means if I work the switch with the tube out, it probably really lets a big whack go on that speaker, so I won't do that. So these are the heaters. Wait a minute. This outside one here is a heater, and that's a heater. That's right, and there's 1, 2, 3 other ones. That's the grid. Nothing on it. Play it again. So put the tube in, and the 62 volts disappears. Okay, we'll put the original back in, tube number 1. I don't get it. There's the voltage. Where's the I think I have this switched to phono now, do I not? When you switch this set to phono, all these tubes remain on, and they're not being used at all. Ooh, what's going on with my image? Is that getting recorded? I had some jumps on the image there. That's just in my shop. Now I'm worried about the video stuff I'm doing. Okay, never mind that. Let's keep a go. So now there's a voltage there. 47 now. Wasn't it 62 just a minute ago? Oh, I'd love to hear that crackle and see this voltage jump around. It's 47 now. What happened? Why are we not hearing anything? Quick. Tracer on the grid. Tracer on the grid. Tracers on audio. Okay. Okay, we're back to RF. Oh my gosh, this can't fall off. This piece off, there's a really good chance of a short happening in here. Stay on there, man. Nobody home. Why? It's extremely low now. Oh my gosh, what am I doing here? What has happened? That is the question. That is the question. Antenna. Handle the volume here.
See baseball questions. We'll do our best to answer them. Both
that's what's on the
show
antenna.
and on
No,
Twitter.
without adjusting the volume. That's all that's making it now. What happened? What has happened? Oh, baby. You know what? Everything's gone down here. Everything's gone down, including that voltage. Is something pulling the power supply down at this point? Oh, I can't leave that there. What's going on? What's going on? Full power. Plate voltage. Plate voltage to here. $140. $40. $140. $140. So I can hear something in the speaker while I'm accidentally injecting some noise into the plate circuit of this tube, which is essentially the grid circuit of this tube. What? Come on. Am I right on that? Maybe I found the problem right here. So, couldn't have. I hear the signal over here, past this tube. I was thinking the signal was being blocked at this tube. But I hear it over here. Can I try reading the voltage on the grid? Well, that's interesting. Now that's coming out of the speaker of the radio, of course. The signal tracer is not hooked up. So I'm injecting a noise into the grid of this tube that's coming out of the speaker. Wait a minute. I gotta inject a noise. You hear it. The radio signal's there. Okay, this is on radio now. Did you see that speaker pop? Wow. What has changed? A lot has changed. All I did was pull this tube out, swap it around a couple times. Really? It's crazy stuff I do. Okay, gain. Radio signal reaching the grid. Hey, I lost my top. Radio signal reaching the grid compared to what's right on the antenna.
Get out of his spot.
So it's a lot of work reducing the signal to the point where there's nothing left. Let's just go again. I gotta start right at the start here. So from the antenna over here. What's with all that popping? Did I hit? Oh, no, from the antenna here.
Open looks. He's, going to be a facilitator, of course. He's probably.
I got the volume turned down on this. And the answer would be yes.
Warriors trying to get the ball in.
So I had the volume turned down. That's part of the problem. Back to the grid.
Flames.
Beautiful. Okay. I got a real humdinger of a signal on the grid of this tube. Nothing for us to hear. Now, for sure, is this switch right? Pretty sure it is. Correct? Just send that straight to the speaker.
Continue tonight in game number 2. So we will have game 2.
They just give me no end to basketball talk here. Audio. Oops. Audio. So I'm not going to guarantee that's real audio. I got the levels up so high on the tracer here. I just seem to be going around and around in circles. Now we have our 40 volts or so on the plate. Yes, we do. 46. That's perfect. So come on, tube. Do your thing. And we have 40 all the way on this coil. So that's coming out of the radio speaker. Two defective 27s, both doing exactly the same thing, which is nothing. Or something's going on underneath this tube socket. Or I've just lost what few brain cells I had left. They've just gone. I'm just sitting here totally empty-headed looking at something that should be obvious. But boy, it is not obvious. Tube driven into cutoff because the biasing is bad. Wouldn't matter which tube you put in at that point. So let's see. We're going to try to read the grid voltage to the chassis. Show up here. It's negative. Now, as soon as I hook up the meter, I probably bled down some of the. How come you can hear that? How could you hear that? What the heck is going on? Okay, on audio with the signal tracer. No, there shouldn't be any audio there. There shouldn't be any audio there. I'll just leave it on there. So there's an audio hum obviously coming from my. I'm sorry. How come that meter's going up and down? Well, it could be because I'm putting this on and off. Okay, switch this to audio. RF rather. So now we're just hooking up a radio to this point here. How come we don't hear a darn? What the heck? Volume. Okay, so that's the signal tracer volume.
He's made some real good improvements with his slider. It's become a real effective outpitch for him.
So when I touch this to the lead, I hear a slight drop in the signal tracer.
They've been great this year, but I think Oda Rizzi's the kind of guy who will be in the.
And the hum you hear, this is weird, the hum you hear is coming out of the radio speaker, not out of the tracer.
Pitching it out, move as much. You know, he's got the power sinker, which, you know.
Holy smokes. I don't get this. If I inject an audio signal here, we hear it. But there's a big blasting radio signal there. Two defective 27s. I don't know what else to think. Two defective 27s that both test okay. Good enough. But I don't get it. Well, I don't know. I'm looking underneath right now. There is nothing underneath here except the terminals sticking down. There's no wires, there's no connections, there's nothing underneath this radio to be a problem. Jeepers creepers. Well, I don't know what to say. Yeah, I don't. Well, I'm going to leave it at that. Maybe. I thank you all for the ideas. You've been putting on some comments. I've been looking through them. Everybody's lost on this so far as I can see. Defective 27. I don't know. Okay, there you go. Sorry this isn't going somewhere exciting and wonderful, but you know, I am doing these things essentially live. I really don't know what to expect when I come in here, and so who knows what's going to show up on my videos, including this kind of a dead end. Oh well. I'm going to go outside where the sun is shining, the grass is growing, and all the plants need planting. I'll see you on the next video.